In this episode, we prove that the cell can remain stable in conditions that are almost double what typical lithium-ion cells can operate in. These conditions are 80 degrees Celsius and 100 degrees Celsius.
Donut Lab won't stop until they truly convince people that their solid-state battery is a real miracle. Every 2 weeks, a new test is released. And this time, they've just announced the results of a second independent battery test, in which the cells were heated to 100 degrees Celsius and discharged. Snorts. The truth is that most conventional lithium-ion pouch cells suffer severe degradation and face serious overheating risks. At this temperature, the batteries can explode or catch fire. Yet, Donut Lab's solid-state battery reportedly shows an almost absurd increase in capacity. We understand that some people just want the headline up front, so we'll give it now, and then anyone interested can watch the rest of the video where we explain why we believe Donut Lab's solid-state batteries still hold many unresolved mysteries. So, is this the scam of the century or a revolution previously? In the first independent test, Donut Lab demonstrated that their battery could charge from 0 to 80% in just 5 minutes. The result was genuinely impressive, but it also sparked plenty of controversy. In the second independent test, the Finnish company aimed to prove the battery's performance under high-temperature conditions. As before, the second test was conducted by VTT. VTT is Finland's largest state-owned and state-controlled applied research organization and technology research center. It's important to note that VTT only tested what Donut Lab provided and followed Donut Lab's testing plan exactly. Their role was not to prove or disprove anything. They simply carried out a service according to the client's request. So, what does this new VTT test actually show? VTT tested a Donut Lab battery labeled DL2 with a nominal capacity of 26 amp-hours and a nominal energy content of 94 Wh. To put that into perspective, a typical iPhone battery only has a capacity of about 3 to 4 amp-hours. That means Donut Lab's 26-hour battery is roughly 7 to 8 times larger than the battery in your phone. The Donut battery was placed inside a climate chamber, and this time VTT applied a 2.4 kilograms steel weight on top of the battery to create mechanical pressure. Meanwhile, a temperature sensor was positioned underneath the battery, an essential detail for high-temperature testing. First, the battery was kept in the climate chamber at 20 degrees Celsius and allowed to stabilize for 1 hour. It was then charged with a constant current of 24 amps until the voltage reached 4.15 volt. After reaching this level, charging continued at a constant voltage of 4.15 volts until the current dropped to 1.2 amp in the first test run after charging was completed and the battery rested for 1 hour. It was discharged at a constant current of 14 amps until the voltage fell to 2.7 volt. Finally, the results of this process showed a battery capacity of 24.9 ampere-hours. We know some of you might feel a bit overwhelmed by the numbers, but essentially, this first test step simply shows that the battery was charged and discharged under standard conditions to determine its actual capacity, and the measured result was 24.9 hours. So, what does this actually mean? It's easy to see that the 24.9 ampere charge-discharge result measured at 20 degrees Celsius in the climate chamber is about 4% lower than the stated nominal capacity of 26 amp-hours. And this is where things start to get interesting. After the battery was fully charged using the standard procedure, the temperature inside the test chamber was raised to 80 degrees Celsius and held there for 2 hours. At this temperature, the battery was discharged at the same 24 amp rate and delivered 27.5 hours, reaching 110.5% of its room temperature capacity and exceeding the 24.9 hours measured at 20 degrees Celsius. Finally, at a temperature of 100 degrees Celsius using a discharge rate of 12 amps, the battery delivered 27.66 amp-hours, corresponding to 107.1% of the reference capacity at the same discharge current. Yeah, basically the 100 degrees Celsius test was conducted at a 0.5 C rate, only half the rate of the 80 degrees Celsius test. So the two figures cannot be directly compared. What is quite interesting is why they did not test at 1 C at 100 degrees Celsius. We do not fully understand this. If you have an explanation, please let us know in the comments below. However, there is one notable issue. After discharging at 100 degrees Celsius, VTT observed that the battery pouch had lost its vacuum. The battery was still functional and charged normally afterward. But the outgassing suggests that either the packaging or the battery's chemistry generated gas at that extremely high temperature. Based on what we have found, standard pouch packaging typically uses a polyolefin adhesive to bond the aluminum layers to the inner polypropylene layer. This type of adhesive melts at around 85 degrees Celsius. Testing at 100 degrees Celsius may have compromised it. Initially, the company claimed that the battery operates safely across a temperature range from -30 degrees Celsius to 100 degrees Celsius while retaining over 99% of its capacity. VTT's actual data shows that the battery exceeds its room temperature capacity even at elevated temperatures, which is even better than the claim regarding absolute discharge performance. However, VTT did not test ATIS 30 degrees C, and the loss of vacuum in the pouch at 100 degrees Celsius raises questions about long-term durability under such extreme conditions. That said, we should also be fair and give Donut Lab the credit it deserves. 2 independent VTT test reports within a 2 period, both confirming specific claims, demonstrate a level of transparency that exceeds that of most battery startups we have seen. The high temperature results are particularly significant. Maintaining and even increasing capacity at 80 degrees Celsius and 100 degrees Celsius is something conventional lithium-ion batteries simply cannot do. As we mentioned earlier, conventional lithium-ion batteries are very sensitive to temperature, and their maximum operating temperature typically falls in the 60 to 70 degrees Celsius range. At higher temperatures, the risk of battery damage increases, reducing lifespan. In addition, high temperatures can accelerate internal reactions and, in the worst case, significantly increase the risk of thermal runaway. So with this second test, it essentially shows that the donut battery has a fundamentally different structure because it does not contain a flammable liquid electrolyte, allowing for a higher maximum operating temperature. However, there is another caveat in the documentation that we need to clarify. VTT did not verify whether the tested battery was truly a lithium-free solid-state battery. As with the first report, the second report states that VTT conducted tests on an energy storage device provided by the customer and identified by the customer as a solid-state battery. After the first test results were published, some experts publicly challenged the claim that the battery operates without lithium.